Hello, Year 11s. Hope you are well. Apologies for the delay. I haven't been feeling great today. I've had a bit of a migraine, but that's not important. Let's get on with the lesson. So, do now. This is the first part here. So, press pause and have a go if you want to complete these questions first. And then we have this question here as well. So, press pause if you want to have a go with this one. So let's go through the answers. Okay, so in terms of this, so in terms of answering this one here, tablet. Okay, so in terms of answering this one here, the main thing you need to remember is we're timesing this by a half. We want to make V the subject. Timesing by a half, you could actually write this like this instead. So E equals mv squared over 2, because that's the same as multiplying by a half. So then what we would do to start rearranging the equation is multiply both sides by 2. So that would give you 2e equals mv squared. Then divide both sides by m. So 2e over m equals v squared. And then final step would be to square root both sides. So that would give us a final answer of v equals square root 2e over m. Okay, so for the next one here, this is our nice surds. So the best thing to do is actually to multiply these together. So you end up with square root 5 times 15. That would give us square root 75. And then we want to break that down into factors where 1 is a square number. So the biggest one that comes to mind for me is 25 goes into this. How many times does 25 go into this? 3 times. So I can write that as square root 25 times square root 3. Square root the 25, which is 5. And square root of 3 stays as it is. That's your final answer there. Okay. So for this one here, we want to find BC. We want to find this bit here. Okay, so to find BC, the first thing we need to do is find BD. Okay, so we're going to use Pythagoras to find BD. It's a shorter side. So if you write as it would be normally, a squared plus b squared equals c squared. Well, we have c squared. We want to find, let's say, a squared. So we know that we would do c squared minus b squared to give us a squared. So let's put those values in. So our c would be 10 minus b squared, which would be 8. And our a squared represents bd. So let's write bd squared. Okay, so let's pop that in the calculator. So that gives me 36 equals bd squared. And hopefully you know that 6 squared is 36. So bd is 6 centimeters. Okay, so I'm going to write that in here. So we've got 6 centimeters. Okay, so now based on this triangle, we want to find BC. So now we're going to use our basic trig ratios. So in relation to the triangle, this is our adjacent because it's touching the angle, and this 6 would be our opposite. So our trigonometric ratio we're going to be using is, of course, TOA. And we're looking for A, so we cover it up. And we're going to be doing O divided by tan of the angle. Okay, so if we write that, so A, or if we write, sorry, BC is what they're calling it. BC equals O divided by tan of the angle. And then BC, put the values in. So 6 divided by tan 20. That will give us BC. And that gives us 16.48 to 2 decimal places in centimeters. Okay, so that's our answer for this one. Please press pause while you mark/correct your work. So we have this nice solid that's made up of a cone and a hemisphere, okay? So we want to work out the volume of this solid. So the first thing that you want to do, so in terms of this one, I would work out the hemisphere first, which is half of a sphere. So if you remember the formula for a sphere, so vol of a sphere is 4 over 3 pi r cubed. And we know we're going to do this and divide by 2 once we're done. Okay, so let's put in the values for this. So the volume of the sphere, so volume of sphere, hemisphere, you know what I mean. Let's write that. It makes more sense. So volume of H sphere. So vol of HS. So we put the values in. So we're going to have 4 thirds times pi times my radius is 3, so 3 cubed, and then once we have that, we would of course divide it by 2. Okay, so I'm going to type that in my calculator and write my answer down just here. Okay. So that gives me an answer of 56.54866. 54866. Okay, so the next thing we're going to do is we are going to work out the volume of our cone. So the formula for the height of a cone is r squared times h and times it by a third because we only want the volume of the cone times pi. Sorry, that's very important. I forgot the pi. Okay, so let's put in our values here. So we know it's going to be 1/3 times 3 squared times 10 times pi. Okay, so we know timesing by third is the same as dividing by 3. So we will do, that's 9 times, oh my goodness, why did I write 10 there? Sorry guys, wake up, Mrs. Yusuf say. So start again. Times pi times 10 times pi over 3, and then we know that would be 90 pi over 3. We could actually simplify that down because 90 divided by 3 is 30, so it gives us 30 pi, and then that would give us the volume of cone as, I'll just enter that on my calculator. So that gives me oh my goodness, 94.2477. And then if we add those together, so we add the 56 and this one together, so total vol will be 150.796, and obviously depending on what they want you to round it to, so if it was 3 significant figures, it would be 150. If it was 1 decimal place, it would be 0.8. If it was 2 decimal places, it'd be 0.80 because of the 6. So depending on what they want you to round it to. So that would be centimeters cubed because that's volume of the solid. Okay, so press pause while you mark / correct your work. So today we are doing a little bit more of rates of change. So you're going to be looking at density and pressure on pages 62 and 63. But then after that, on page 64, we're going on to geometry. Okay, so we're going to be looking at geometry and polygons and things like that. So that is your task for today. I was going to ask you to do the higher +5 a day, but it's up to you. If you want to have a go, I will attach it in the links. There is some function graphs there, so please do look at the answers to make sure you're comfortable with that, people that are pushing themselves. Okay, so hope you're working well, Year 11. Please do send me some lovely work. I will be contacting some of you individually soon because I finally received some lovely letters that were left in my pigeon tray. I only received the ones that were unopened, that were not sealed, sorry. So that was 4 of those. I think it was 4 or 3. I can't remember now. And Mrs. Barker kindly sent me images of those, which were amazing, made me cry a little. But 2 of them were sealed envelopes, so she didn't want to open those. So I will have to open those at some point when I pop into school. Yes, so I will be emailing those students individually, but many thanks for that. I really do miss you guys. And remember, I'm here for maths help or any other help. I will always do my best to help you guys. All right, take care. Speak to you soon.